So hello, good afternoon, everybody, and welcome to this new online event at EPIC. After a very busy annual general meeting last week in Helsinki, some of you were present, and I hope you enjoy, and it was a successful week for you. We are coming back with our online activities, and it's time today for our new EPIC members' new product release. Before Easter holidays, we have the opportunity of learning more about the new products of some of our EPIC members. For starting, just a few words about EPIC. EPIC is the European Photonics Industry Consortium. It's an association of more than 100 members, and our goal is to ensure the sustainability of the photonics business in Europe. As you can see in this slide, apart from the 800 members, we are this year in our 20th anniversary, so we are preparing a very nice party in the next Laser World of Photonics. So check our social media and our website for more information about that. And about EPIC, as I mentioned, the European Photonics Industry Consortium, this is the nice EPIC staff that is helping the members to have access to the new information and to solve their technology needs and requests in case you are looking for a partner, a collaborator, in case you are looking for a supplier of a component, or you are interested in going into a new market, we can help you with that. We can also provide access to market reports. We are organizing different networking activities where you can connect with a lot of different industry from the whole supply chain, components manufacturers, integrators, end users, software designers, and so on. You can have access to markets, also be in contact with mentors, and we also can support with your human resources needs. And we can also be at the contact point in case you are looking for investor, or if you are a company that are interested in invest in certain markets. So this is a summary of the benefits, and I encourage you to contact me in case you are interested in joining our consortium, or if you have any doubt or any request, please do not hesitate to contact me or any of my colleagues. And let's go with the agenda for today. So as I mentioned, the meeting for today is about new products. So we are going to learn a lot about the products that our members are launching. We will start with Ksenija Varga, the business development manager at EV Group. We are going to learn about the solution for metrology, for maskless exposure technology. We will continue with Lukas, Ceizaris, Chief Marketing Officer at OPTOMAN. He's going to talk about the coating solutions for the erbium young medical lasers in the mid-infrared region. We will continue with René Dingshoff, the Senior Technical Manager at SFC Energy. He's going to tell us more about the new power supplies for high-power laser applications. We will continue with Pierre, Brochard, President at SILENTSYS. We will know about the optical frequency discriminator for laser characterization and installation. And we will finish with Alexander Chamorovskiy, the CTO and Director at Superlum Diodes. And we are going to know more about their ultra-compact superluminescent diodes, light sources, and some of the applications they have for them. So it's time to start. So I will stop sharing my screen. And Ksenija, please, the floor is yours. So we are curious about your solutions.
Mm-hmm. You should see my screen, right?
Yeah, perfect. Thank you.
Good afternoon to everybody. Thank you to the EPIC team to give us, to EVG, opportunity to present the EVG and the tool here, and thank you for your kind introduction. In today's session, we would like to show the metrology tool. We launched the newest generation of the tool. We launched just recently. It was 1.5 years ago. EVG 40 NT2. It's a metrology system, and we are now in this presentation focusing on the measurements of the lithographic patterning performance from this tool. Just shortly about, I did not prepare extra slide about EVG. We are a family-owned company based in Austria. We have globally 1,200 people employed. We are very, let's say, popular or positioned in the bonding equipment market, in the lithography and nanoimprint lithography, and as mentioned, we are having also metrology equipment. Good. Metrology equipment, we have different kinds. Please interrupt me if I speak too much if I overexceed my 5 to 6 minutes. So we have two kinds of metrology system, like standalone metrology system and also integrated metrology system. Within the standalone system, we are doing more customer based or according to the customer specification. We have pass-fail criteria. The feedback loop is host controlled to all relevant processes. And the most advanced, or we are positioning more frequently, is the integrated metrology, where we sell the tools in package with the other systems. And we are getting, it's more advanced, we are getting the customer can get direct feedback, and we have corrections of the process parameters. Good. We have really very broad global positioning already achieved with this NT40 series. We have even more than 120 installed systems on the global scale, US, Europe, and Asia. We are serving the tier 1, of course, semiconductor fabs, as well as smaller institutes or R&D facilities. And we are promoting the tool for the lithography and bonding applications and the whole range of advanced packaging, 3D and the heterogeneous integration applications. About the history. So with the metrology tool is more or less the newer part of the business. The colleagues or the engineers started early 20, and then it was primarily based for the lithography process parameter measurements, then expanded to the next generation. And the newest now generation we launched late 2021, half a year ago, and we are promoting the tool for the bonding applications and the whole advanced packaging application, heterogeneous integration industry. In this short slide, we are having the different technologies, as mentioned in the beginning, because we are kind of limited with the time. We are focusing on the application of this metrology system to measure the parameters within the massless exposure lithography or the lithoscale tool. Good. We are measuring with this tool. We have a topside alignment, very good procedure. We are measuring CD, of course, as a basic parameter of the lithography, and also we are having dual layer alignment, also very high precision. We are using the visible and infrared lights in this case. So what is so special? We have microscopic, of course, features and mechanical, like chuck features. Within the camera setup, we have CMOS, of course, image sensors, then infrared cameras. We have different kind of illuminations. We can achieve really high level of magnification, 50 times magnification. It's, let's say, based on the customer request. High level of autofocus. We have automatic search of the focal plane of the alignment kits. We have multi-point alignment kits. We are using this for the optimized measurement performance, and we have really good wafer-to-wafer repeatability. Okay, and then at the end of my short presentation, we are promoting even more strongly this metrology tool in a package with a massless exposure lithography. By integrating this tool, we can achieve individual die shift compensation, which are occurring during the heterogeneous integration processes. We are measuring, of course, CD. We have high resolution mask alignment verification, and then when it comes to the lithographic patternings, we have real-time process corrections. And with this metrology tool, we can state that, and with the integration with the other technologies, we can help the whole supply chain, the semiconductor supply chain, to accelerate the market launch of the new products or new applications, so we can help for the device manufacturers, foundries, advanced packaging houses to be faster on the market. I think this would be all from my side. Thank you for listening. I'm open for a couple of questions, and in the case there are detailed technical discussions needed, of course, we are open to have a follow-up call with our experts, with product managers and engineers who are dealing from the technical perspective with metrology tools. Thank you.
Thank you, Ksenia. Very interesting.
I think
so, yeah, so no, it's okay. Very good in timing. Thank you. And it's time for questions. As Ksenia mentioned, we encourage you to join as a panelist, also to raise your hands, switch on your camera so you can make your question directly to Ksenia. I can start because I have a couple of doubts. I don't know if in this kind of application, the measurement of the thickness of layers could be interesting in the future, or for now it's not a request that you have from your customers or from the users of this kind of technology.
As mentioned, the technology is used for the measurement of the whole lithographic parameters and the processes from the global customers base. Yeah, so we are very well positioned, and I hope with the EPIC network you can help us to get new concepts and then to expand our network. And then,
but the thickness of layers is something interesting for your customers, or is something that perhaps is not interesting for this application?
Yeah, layer thickness, of course.
Yeah. Okay. And my second question is, can these solutions also be implemented in existing machines, or is or something that you offer with the new machines and you sell as a package?
No. We are, as you stated, the technology is developed, and we can offer it in the packages with existing technologies.
Very good.
Of course,
very interesting.
Then we will launch the next generation of other technologies. Together, we will launch the next generation of the metrology tools. But yes, we can offer it at the moment with the existing tools.
Very good. Really interesting solutions, because I think it's one of the things that is very important is to follow the parameters when the process is running, so the customer or the user can well put some effort in changing the things that must be upgraded. I don't know if there is any other question for Ksenia. If not, thank you very much for your presentation. It was really interesting, and we can move to the next speaker. So in this case, we are going with Lukas Ceizaris, Chief Marketing Officer in OPTOMAN. So Lukas, feel free to share your screen and tell us more about your coating solutions.
Yes, am I sharing the right screen?
So we have the same as in the test, so you should go to again display settings and
yes,
and press the swap. Good.
Okay.
Thank you, Lukas.
Thank you. So I'm Lukas, and today I will introduce our new addition to our product portfolio, which is low absorption and enhanced lifetime coatings for erbium-YAG medical lasers. But firstly, let me quickly remind you who's OPTOMAN and what does OPTOMAN do actually. So the answer could be really quick. OPTOMAN does laser optics, as you can judge from the company name OPTOMAN. But I would like to elaborate a bit more and mention that we always dig deep into applications of our customers, so we could provide the really customized and application optimized optics. And we always aim to increase the reliability and longevity of our products. So eventually our partners, our customers could benefit from lower total cost of ownership. We are a fairly young company. This year we're going to celebrate our 6th birthday. And for this year, we project 5.5 million euros in revenues. And a big fraction of this number actually comes from the medical laser manufacturers, as it accounts for 14% of our total sales. And well, basically it's because we share some of the same values, as both of us try to make reliable and durable products. Erbium-YAG lasers, this is the topic that we optimize the optics for. Erbium-YAG lasers have been used for cosmetic surgeries as well as dental procedures since the 90s, actually. And it exploits the water absorption. As you can see, the water has this peak in the absorption coefficient near the 3 microns. So what erbium-like lasers do, actually, they cut the tissue by using the absorption by the water inside that tissue. So the absorption is what enables erbium-like lasers to be so effective for their purpose. However, the same phenomenon is actually a headache for coating manufacturers as OPTOMAN, because absorption is a driver of thermal effects. High absorption means a low duty cycle, and it is the main cause of laser damages. And it actually made us even to develop the specific character for this phenomenon called Dr. Absorption. So he's the arch enemy of OPTOMAN. We always try to fight him. And ion beam sputtering technology, IBS machines, help to fight Dr. Absorption, actually, because IBS coated optics feature bulk-like density. So the coatings are really dense, and they don't have any unwanted impurities inside the coatings, which could absorb the laser pulse. However, what we have discovered, just simply applying IBS for 3 micron coatings was not enough. Here you can see the gray line indicates the absorption values of coatings just after the coating. So what we have discovered is that apart from the need to densify the coating, we also need to look into the stoichiometry, as we have to eliminate oxygen and then some hydroxide particles and bonds that still remains inside the coating, because they are still highly absorptive at 3 microns. So we have to keep stoichiometry as well perfect as possible. And here you can see that this green ish line indicates that we were able to achieve 0.5% for the absorption value at the desired wavelength when manufacturing anti-reflective coatings. And we were able to do that by introducing some post-coating treatments, as well as optimizing the coating parameters. And obviously, this is not the limit, actually, what we can achieve. We always, go beyond that, and we already have a plan in place how to achieve 0.2 and less absorption values for anti-reflective coatings. Apart from anti-reflective coatings, we also do other type of coatings, and we also made high reflective coatings used as a cavity mirror. So we achieved 99.8% reflection values for this case, and as well, we have manufactured a few output couplers, so partial reflective coatings, maintaining 1.5% deviation from the desired reflection. And well, this is actually the slide which I want you to take away from my presentation. This image here, even though it's a beautiful image, it's a laser damage, and we want to avoid that. And it doesn't matter how strong, how fast, how awesome your laser is, it is still as durable as its weakest link. So optics as a part of the supply chain has to be looked into strategically. And well, my suggestion is to trust your psychic for laser optics development, which is OPTOMAN. Thank you. Well, that's all.
Thank you very much, Lukas, for all this review to your coating solutions. It's time for questions. So any questions for Lukas? I have one regarding the particular case of the medical lasers. We talk about the wavelength and the absorption, but is there any other parameter that are specific for the medical lasers, different from other lasers for micromachining? I don't know, power distribution or the beam shape that makes complicated for you to design a coating for them? Or apart from the wavelength and all the particularities, the other parameters are more or less standard?
Mm-hmm. Yeah, so what I have noticed that medical lasers, they really will require the durability. Well, durability can be understood in two ways. So either it's just, maintains a high energy pulse, or it's, resist the degradation of the coating. So the degradation is a really big need to solve the degradation for the medical lasers, and well, IBS helps that. Also, some requirements for specific well, multi-wavelength solutions. So, for example, for articulated arms, when you need a reflection at a few different wavelengths. So it is sometimes a challenging coating, and yeah, so this is also one of the characteristics.
And when you are talking about medical lasers, are you mainly focusing, let's say, photo treatments or this kind of solutions, or are you also working with companies doing like surgical lasers, for example?
Yeah, well, both. Yeah, aesthetical lasers, also ophthalmology, and yeah, we like apart from erbium YAG lasers, we also do optics for Holman based lasers. Yeah.
Okay, very good. Thank you, Lucas. Any other question for Lucas from OPTOMAN? Well, if not, thank you again for this very nice review of your coatings. And we can move to the next speaker. So the next one is René Dingshoff, Senior Technical Manager at SFC Energy. We'll continue in the laser, let's say, wall, but now in the power supplies. So René, the floor is yours.
Yes, thank you. Do you see my screen?
Yeah, we see.
Okay, thank you. Okay, thank you for this opportunity to present our newest power supplies. Yes, we have two new power supplies brought on the market lately, so I'd like to present those, but something is going wrong. Yes, now it works. First of all, a brief introduction of our company. We are SFC Energy. By the way, I have a strange bar over my screen. Do you see it or not?
No, I see the screen good.
Okay,
with the red pointer over there.
I'll continue. Yeah, we have about 300 employees, and we are spread out over the world in 5 locations. Germany headquarters. I myself is in the Netherlands. Then we have a US office, Canada, and Romania. And we do different things. For instance, in Germany, we do fuel cell systems. We have a division of coils and linear drives. And in Holland, we mostly do power supplies. And that's what I'm talking about. I like to introduce 2 new products. That's the LOPS R series. That's a laser power supply in the range of 8 to 20 kilowatts. And we have a laser current driver system, our LEX system. We'll start with the LOPS R series. It's a power supply in the range of 4 to 8 kilowatts in just 3 U or 3 AC height. And we can make voltages from 9 to 180 volts and currents up to 800 amps. Seeing the power, this is typically for the high power laser in cutting, welding, 3D printing, surface treatment, these kind of applications. It's a really flexible system. It's universal main, so you can use it all over the world without any derating. You can put the power supplies in series or in parallel to make higher voltages, higher currents, higher powers. So it's a really modular and scalable system. We have a safety interlock, the highest class that there is, class PLE. That means that you can directly connect your e-stop system to the power supply, and it safely switches off the power when needed. We have a completely galvanic isolated interface that makes it very robust in these high power applications. And you can choose to set the power, the voltage current with either a digital set point through a serial link or with analog values. And there's a lot of control and monitoring inside the power supply to quickly determine if something is wrong or cause of a probable failure. Then we have a really improved transient response compared to any other power supply on the market, basically. That can help you really optimize your system in terms of efficiency and even cost. And then, since high power lasers are very dynamic, we have an excellent capability for pulse loads at basically any frequency. This is the range that we have. Like I said, we start with an 8 kilowatt supply, and we have it in different voltages. Then we go to the 12 kilowatt, 16 kilowatt, or even 20 kilowatt. And like I said, if you need more, you can use multiple of these power supplies in one system. They are all water cooled, so this really matches the cooling requirements of the high power lasers. So then our second product, it's the Lux, and this is a power supply like the LAPS R, but now with also integrated current drivers. So the LAPS R is a real voltage source or a real slow current source, and the Lux is a fast current source, basically, with multiple channels. This comes in a range from 3.8 to 19 kilowatts in the same size, basically. We can put in up to 8 fast current drivers, and each current driver can handle up to 65 volts, 35 amps, so 2.3 kilowatt per channel, and it's also liquid cooled. It has the same universal mains like the other system. It's also modular and scalable. If you want to have more than the 35 amps per channel, you can put channels in parallel. With 8 channels, you can go to 280 amps. And if that is not enough, you can have multiple systems in parallel to go even higher, for instance, up to 1000 amps. This system also comes with a safety interlock class PLE. Also with a galvanically isolated interface with multiple digital and analog set point possibilities and advanced trigger possibilities. I will show you some examples later on. Fast rise and fall time of lower than 6 microseconds. And we have an active overshoot compensation if you, for instance, have longer cables between the power supply and your laser diodes, and an excellent pulse-to-pulse stability. Some examples, what can you do with this system? For instance, if you have an 8-channel fiber laser system, 50 volts, 80 amp per channel, you first need to add some, or have to calculate the power. So you need 7,200 watts. We use building blocks of 4 kilowatt. So we add 2 building blocks. That's a standard power supply that you can also buy standalone. We add the drivers. We add the bus bar systems, etc. And finally, a central controller that controls the whole thing. And in this way, we can build very quickly a power supply exactly to your demands. But we all know that the laser world changes very quickly. So maybe in 2 years, you don't have an 18 amp diode, but a 28 amp. Then, of course, your power requirements go up more than 11 kilowatt. We add another 4 kilowatt building block, and with the same drivers, we can do more power. If you have, for instance, a diode bar with one big output, we can also do that. We first have to calculate, of course, the power, 13 kilowatt. You cannot do that with 3 power supplies. So we're there at the power supply. And now we put all the outputs in parallel. We delete the driver that you don't need, and you have your system ready again. So it's a very flexible system. And with the building blocks that we have, we can adjust very quickly to your needs. Then we have a very flexible way of generating the output currents. You can choose from 2 DA converters or 2 analog inputs, and with those 4 inputs you can basically make any pulse that you like. For instance, if you want just a pulse on and off, you can program the logic in a way that's user programmable, that it switches between the off and the DAC, the DAC2. If you now put a pulse on the trigger signal, it will make the same output current. If you looked at on the scope, the yellow one is the trigger pulse and the blue one is the output current. If you say, oh, I want to have analog modulation, you can do that also. So you just apply an analog signal to the analog. You program the multiplexer that it uses analog 1. You program the logic that it now switches between the off state and the analog value, and you get an analog modulated pulse on the output. Here again, the scope picture, you see the yellow one is the trigger signal, the red one is the analog modulation, and the blue one is the actual output current. We can go even further. You can use multiple trigger signals to make pulses, for instance, switches on and off with trigger 1 or trigger 2, and switch between 2 values with trigger 1, and then you get a pulse pattern like this. So there are many options to do. Finally, overshoot compensation. If you have a short cable between the power supply and your laser diode, your pulse looks very nice without overshoot. But if you increase the length, you will see here that you have overshoot and undershoot. We have a possibility inside the unit that you can compensate for the overshoots. You can store these parameters inside the power supply. Here you see the difference. This is without compensation, this is with compensation. And in this way, it's very easy for the customer with different cable lengths to have an optimal pulse. I hope it was not too quickly and you understand everything. Otherwise, you can now probably have your questions ready. Yeah, last but not least, we are at the Laser World of Photonics and the Photonics West. So if you are there, please come and visit us. This was my presentation.
Thank you, René. Really well clear how to work with these kind of solutions to update or to configure for the different needs. As René mentioned, it's time for questions, so do not hesitate to raise your hand if you want to make a question. I will start with a short one for René. Which kind of companies are you addressing with this kind of solutions? Are you looking for laser manufacturers? Can the integrators or machine builders also customer for you?
Mainly companies that make their own laser sources. So it's part of a big laser, of course. So these kind of companies, but also these power supplies can, for instance, also be used outside lasers. So for instance, in semiconductor industry or something like that. But we are mostly looking for customers that make their own laser source.
Mm-hmm. Thank you. I don't know if there is any other question. We still have time for another question for René. If not, thank you again, René. Really interesting, and I hope you will receive a lot of requests. Thank you for showing also your email address.
Yeah.
You can contact directly him and also the other speakers, on just contact me back and I can put you in contact also with Lukas and Ksenija if you have any other comment or concern that you want to discuss in private. So let's go with the next speaker. And we continue with the laser. We move to Pierre Brochard, president at SILENTSYS. And we are going to learn about this optical frequency discriminator they launch. So Pierre, the floor is yours. Thank you.
Thanks a lot. So I am sharing my screen. Does it work in your side?
It's working. Thank you.
Okay, cool. So thanks a lot for this opportunity, and good afternoon, everybody. So my name is Pierre Brochard, president of the SILENTSYS company. So SILENTSYS is a company that is specialized into ultra-low noise systems, meaning amplitude, frequency, and phase noise. We are active in three main domains: photonics, electronics, and microwaves. I co-founded the company 2 years ago with four series of people. We are based in France, in Le Mans. We are now 9 into the team, and we propose services and products. So we are active in these three main domains for photonics, electronics, and microwaves. We propose both services and products. Just quickly about services. So we are able to help you for some proof of concept, also for studies, analysis, like frequency noise measurement of lasers, of oscillators, or so on. We're also able to build for you a specific, let's say, solutions with, let's say, lasers, electronics, temperature stabilization, and so on. And we also have some off-the-shelf products, like, for example, ultra noise power supplies. For example, if you need to supply very specific components that need a very specific, or let's say, precise voltage supply, we can propose a lot of things with different voltages from, let's say, 3 volt to 18 volt, and with also up to 8 amps if you need to supply something very, let's say, powerful. We also propose very soon balance detection, PID controllers, also temperature controllers, and laser sources and laser drivers. This will be very soon available, but not yet on the catalog, let's say. And today I would like to focus on this product, the new generation of our main product, the optical frequency discriminator. So an optical frequency discriminator, as we call it, OFD, is a simple device that converts the frequency noise of a laser, so let's say frequency fluctuation of the laser, into voltage fluctuations. So let's say it gives you the information of how the laser is drifting in terms of frequency. This is a very compact tool, like a shoebox, high performances, I will describe later. Very easy to use, like a press button, and available for a wide wavelength range. So we can propose a product from 400 nanometer to 2.2 micron. So let's say it can cover a very wide range of wavelength. So how it works simply. So imagine you are in your lab with your experiment. You are using CW lasers. That can be diode laser, fiber laser, other technology of CW lasers, as you can see on the right. Your laser is drifting too much in terms of frequency for application, and you want to stabilize it actively. So you just send through an optical fiber a few amount of the power into our system, like 100 microwatt is enough. So all the power remains for the application. And then our system will convert directly the frequency fluctuation of the laser into voltage fluctuations. And then from this, you have the information of the frequency, let's say, fluctuation of the laser. You can act directly onto the laser to, let's say, narrow the line width, or to frequency stabilize it, or you can just make an FFT measurement in order to reach the frequency noise spectrum of your laser, or frequency stability of your laser. So this is, let's say, very compact, because yes, it's a shoebox. A very small amount of power is needed, and yes, as I said before, it's available from 400 nanometer to 2.2 micron. And also a new feature that is coming soon is that now we will integrate the PID inside the box, meaning that now you will not need an external electronics, but everything will be inside the box, just your laser and our system. And this will, with this, you will be able to make your laser very stable, very narrow limits. So in terms of performances, so inside our system, we have like all fiber optical reference, and this is sensitive to environment. So we really well engineer it. So we temperature stabilize the system, and we also isolate it from the vibration and acoustics. And as you can see on the graph E, we are able to reach a very good temperature stabilization of our system internally, because we are able to reach over 1 day fluctuation up to let's say plus minus 100 microkelvin. And then what we've done on the graph B and C is that we have estimated the frequency noise of our system, or let's say the performance in terms of frequency noise. So on the graph B, we are working with a diode laser, a telecom diode laser from Rio company. So on the red curves, we measured here and shown the free-running laser, as you can see. And then what we have done here is that we have frequency stabilized the laser into ultra-stable cavity as a reference, let's say, and we have made an out-of-loop measurement with our system to reach the green curves. So assuming that the ULE cavity is better than our system, this is like the let's say noise floor we can reach with our system, not, for example, taking also in count this bump due to the lock to the cavity. But as you can see, we're able to reach very narrow frequency noise because we are able to reach less than 10 to -1 per hertz, and also with very low drift. And if you integrate this into line widths, this means that you're able to transform your laser from, let's say, 100 kilohertz line widths into few tenths of hertz line widths. So extremely narrow lasers. And then on the graph C, what we have done is that we have done the same, but at another wavelength with another laser. Here it was with a Toptica external cavity diode laser at 1 micron, and here the same. We measured the noise free running of the laser, and then we stabilize it and made an out-of-loop measurement. And as you can see, we're able to suppress the frequency noise by more than 60 dB. So I hope it was not too fast and not in detail, but thanks a lot for your attention, and please feel free for questions.
Thank you, Pierre. Really interesting solution. It's time for questions again. So please raise your hands to make your questions. I have a question for you, Pierre, because yes. You talk about stabilize the laser when the wavelength is drifting. Mm-hmm. I understand that is trying to get the wavelength that is the emitted wavelength desired by the manufacturer. What about the noise? Is your solution also looking into reducing the noise? Can you talk a little bit more about the features in this sense?
Yeah, sure. The goal is really that, okay, you start from your laser. Your laser has a specific frequency noise, free running, as you can see here on the red curves. And then the goal is really to actively stabilize in terms of frequency the laser to make it a very narrow line width. So as you can see on this graph, we're able, with our system and active stabilization, to go from the red curves to green curves to, let's say, go from 100 kilohertz line widths to a few tenths of hertz line widths. So let's say when you will actively stabilize the laser, you will add a bit of noise, as you can see on this servo bump, so that at high frequency, but then you will be able to reduce the frequency noise by more than 50, 60 dB.
I'm curious about the second input that you have in your solution, in your device, yeah. Because it's because you can connect two lasers, or is the idea to connect two lasers, or yes. Because you are thinking in an external kind of input or an output for other kind of, let's say,
yes. Yes, exactly. So I missed it, but yes, we are providing the system with one optical channel or with two optical channels. This means that with one box, you are able to have two different channels working at two different wavelengths, meaning that with one box, you can cover, let's say, all your laser at 1 micron and all your laser at, 600 nanometer. So with this, you have two independent optical channels inside for two different applications, two different types of lasers.
Very interesting. And I have a final question, because I'm always fascinated about the terahertz wall. It's like a very interesting technology, but it seems that it's taking time to go into the industry or to find real applications in the industry. What do you offer in this field? Is any other product specifically addressed to terahertz?
So here the same. So what we can propose is a system to generate ultra low noise terahertz signals from optics, from photonics. So as you can see from this graph of the OFD, we can also propose an optical frequency splitter with two correlated, let's say, optical channel inside. This means that you can frequency stabilize two lasers, two distant lasers. For example, you have two lasers separated by 5 terahertz, and then you stabilize the two onto the OFD, onto correlated, let's say, reference, and then by beating, you are able to generate a very narrow line width terahertz signal.
Very interesting. Do you have industrial applications for the solution or customers, or are you more in the scientific world still with terahertz?
So actually, we're selling both to companies and to let's say labs, but more and more to companies, and there is a lot of applications that needs very narrow linewidth lasers, and more in this, let's say, compact package and low cost package. For example, there is a lot of sensing application, also all about the quantum applications. So let's say everything related to atoms, to catching atoms, and yes, so a lot actually of this industrial application more than pure labs applications.
Very good. So thank you very much. It was really interesting, Pierre.
And
yeah, you are a quite recent EPIC member, so it was great to learn more about your solutions and this product in particular. So thank you for being here. I don't know if there is any last question for Pierre. Well, if not, thank you again. And let's move to our last speaker. Also a very interesting technology, Alexander Chamorovskiy, CTO, the director at Superlum Diodes. And he's going to talk about his ultra-compact SLD source and some about applications. I can say that a little bit of OCT is going to be mentioned today.
All right. Thank you so much for the introduction. I hope you can see my screen.
Yeah, we're waiting for the full screen. Yeah, perfect. Thank you.
Very good. So yeah, my name is Alexander. I'm with Superlum Diodes here in Cork, Ireland. And together I make a short presentation about our new compact light source. So first of all, a little bit about our company. So Superlum is one of the pioneering companies in the commercial superluminescent diodes, low coherent light sources, with some key SODs developed by Superlum in pioneering works in spectral domain, optical coherence tomography, animation, and also sensing and metrology. So we are a small but very dedicated company with a number of awards for our work with superluminescent diodes. And we continuously deliver products to companies from the Forbes 2000 list. Our primary markets are optical coherence tomography, optical sensors, and other non-destructive testing and low coherence sensing like speckle-free optical illumination, optical spectrometers, and so on. Today, our core business is associated with the superluminescent diodes, and but we also supply traveling wave semiconductor optical amplifiers, gain chips and modules for the customers. We also provide OEM integrated light sources where SLD or an SOA is combined with the driver. And we also provide the benchtop solutions for the universities. And today, based on, okay, sorry, just like went off. Today, I'm presenting our most compact solution to date. It's a BLL, a very compact broadband light source where any SLD of ours can be integrated. And this is a digital driver with the computer controls, animation, and sorry, resume share. Sorry, some technical difficulties. Sorry. And this light source is basically compatible with most of our light sources. On the next slide, you can see it's very small, and it's also designed to be integrated on the PCB boards of the customers because the compact sizes is actually right now the driving factor for the industry. So we are providing the most compact light source. Right now, we are providing like the performance examples, like the stability performance with the temperature, ambient temperature variation from -5 to 50 degrees. And you can see very little drift, which shows like the great stability of this driver. Which can be used like from -5 to +50 degrees in active use with very little with fluctuation in terms of power, which is very good because number of applications where Superlum is delivering require change in temperature without actually like a fault of the use, or very where the light source can be easily accessed. So another one is just like we demonstrate that this very compact driver, it also has very low noise, which can show the relative intensity noise on the left, with the RIN values very like, except for like 1/over frequency component on the level of the quantum noise of the SLT driver, with no extra noise from our controller. And on the right, you can see the modulation pattern in 10 kilohertz, because the driver also supports the active modulation of the SLT module. These are examples provided with our best-selling Superlum diode at 850 nanometers for ophthalmological applications, like 50 nanometers full width half maximum, and 10 milliwatts of power. I should also note that the BLL driver light source can also be supplied with the evaluation board, because itself is designed to be integrated on the PCB board. But we can provide the evaluation board where the driver can be put in without any additional services, and it can be connected to your PC and remotely controlled and be set up, which is very good for setup and use in the laboratory environment. So why choose the BLL over like our light sources? Again, it's a very compact size. You can see just basically just enough bigger than the standard 14-pin butterfly package. It's a very high stable for the and insensitive to the ambient temperature fluctuations, and the low noise driver. It's designed for integration on the PCB boards. It's a digital driver with UART and USB connectivity. I should also point out, while it's designed for SLDs, it is also compatible with semiconductor optical amplifiers and laser diodes, so things that we are also investigating. So anyway, thank you so much for your time. I'm open for questions, and you can also send us an email to our team, and we'll be happy to see you at the Laser World of Photonics in Munich. Thank you.
Thank you, Alexander. So I will definitely pass by your booth to see what do you have there. Any questions for Superlum? I have one curiosity, because well, we were talking before about the OCT, and I know a little bit of this kind of technology. But do you have in mind any other applications related with health or medical market, let's say, for this kind of SLDs? Which we saw about with Lukas about this kind of erbium lasers for medical applications. Do you have something in mind for this diode?
So because we supply diodes in the wide wavelength range from like roughly like 600 nanometers to 1100 nanometers, and there are different applications, not only ophthalmology, but now the growing market would be for different types of the blood sensing applications in different types, and also skin measurement applications. So different types of skin diseases can also be accessed with this wavelength range. So anywhere. Do
you also have contact, let's say, with this wearable devices manufacturer? Because I see that your sources are quite compact, but
well, they're not. I would say they're not that compact. I mean, we are now entering the market for light sources for not just a wearable, but let's say something that can be some medical devices that can be placed in your house. So, or at least like in every glasses store or ophthalmology store in your shopping center. So this type. So for wearables, we are not yet there, because our light source, I would say, and even SLD chips itself, they are quite big. But for something that can be placed in house, not only like in the hospitals and medical institutions, but in house and or in shops, yes, they are. We are there.
Yeah, there are more and more point on care devices, right? For
exactly.
measuring at home and in different, let's say, clinics that are not perhaps hospitals. So yeah, very interesting. And I really would like to meet you in Munich to talk a bit more in detail about this application, because I'm technology manager also for biomedical market. So it's really interesting to see how photonics is more and more used in this application.
All right.
So I don't know if there is any final question for Alexander. We still have a few minutes left. Well, if not, you saw, I think, the poll that it was launched, so it would be great if you can answer. So we will have feedback about this event and how to improve for the next ones. And I will finish with just a few words on my side. So I hope you can see my screen. I would like to thank again all our speakers. So Ksenija Varga from EV Group, Lukas Ceizaris from OPTOMAN, René Dingshoff from SFC Energy, Pierre Brochard from SILENTSYS, and Alexander Chamorovskiy from Superlum Diodes. Thank you to all of them. As I mentioned before, you saw all the emails or some emails from them in their presentations, but do not hesitate to contact us as well if you want to discuss more in detail or know more about their products. And to finish, just a few words about the next EPIC events. As you can see, we are still doing a lot of online meetings because a lot of members are requesting to have access to this opportunity. But of course, we want to go back after the COVID era in the physical meetings. So next ones will be a meeting on fiber sensor in Porto, hosted by HBK Fiber Sensing. We will have a couple of delegation trips in the next months. The first one to Abu Dhabi and the second one to Canada in May and June. In case you are interested in knowing more about how is the photonics business in other countries and also meeting companies there, we are organizing different delegation trips to other countries, also Korea, if I can mind, India as well. So do not hesitate to go to our website, check and register for the countries you are interested in. As I mentioned, finding new companies, perhaps new distributors, and to explore the business there. And of course, in late June, Laser World of Photonics, it was mentioned several times in the presentations today. So we will also have different technical meetings. Of course, we will have a booth there, so you are more than welcome in our booth for discussion, or if you are interested also in having a meeting with any of your customers. In parallel, we have an EPIC meeting on micro-optics on June 27, one of ultra-fast laser processing, June 28th, and a technical workshop on photonic integrated circuits, post-processing and packaging on June 29th. So we try to cover the different topics that our members are exhibiting in the show. And regarding online meetings, next one is an EPIC market report about non-telecom pixels applications and also pixels for 3D imaging. Then we have online technology meetings on photonics for climate monitoring, one on focus on additive manufacturing. Then we are combining technology meetings with also marketing meetings, so you can benefit of the experience of our marketing team. And in this case, they will discuss about the press content for photonics. And in June and July, we have these two meetings on agriculture, on laser weeding, and photonics for wearables. So my question to Alexander was also in this direction, just to see if there was also some interest over there. So thank you again, and I hope you enjoy the meeting as much as I did. So thank you to our speakers again, and I wish you a great afternoon. See you in our next EPIC meeting.
Thank you.
Thank you very much.
Thank you.
Thank you, everybody.
Thank you.
Bye.